Hello everyone. Today we're going to talk about the greedy algorithm, and the key concept of it is making the best decision right now, not based on the past without knowing the future. All we have to do is just focus on the present moment. And so sometimes it's pretty hard to come up with the best decision in the present moment, but it sometimes works perfectly without any other exception. And so let's go straight to the business with the real life example today. Well, let's say you work at the gift wrapping center and each gift has a fixed volume and you must pack it exactly. We always choose the largest box that fits into the remaining gift size. So we have the box size of 100 and 25 and 5 and 1. For example, a gift of size 100, we use only one 100 size box. And for a gift of size 125, we use one 100 size box and one 25 size box. And when it comes to a gift of size 286, we take two 100 size boxes and then three 25 size boxes and then two 5 size boxes, and finally one size box. So it all comes down to 8 boxes in total. Long story short, the goal is to minimize the number of boxes by using the largest possible box all the time. Well, first things first, I'm gonna write down the basic code first. Well, when it comes to box size, it will be 100 and 25 and 5 and 1. And so let's say the gift size is 286. The box count must be uh, the gifts should be divided by the box size, and we need the remaining volume, and this is how we get the remaining volume from the gift size, and we need to update with the rest value, and we need to accumulate the box count value to the value of total. There we go. And then if I print out the total value, it must be 8. What about 141? 6 over 100, it must be 1. And 125. Lastly, 99. This is 11. There we go. Imagine you manage a space launch station, so only one rocket can be launched at a time. So each lines represents the time range of the rocket launch. And so the bottom line is that we want to launch as many rockets as possible with the given time. So if a launch ends early, it leaves more space for future launches. So basically, it is a end time based greedy algorithm. So I already sorted out based on the end time. So first things first, we can select this rocket, and then we're supposed to select this one because it ends the second earliest, but time range is overlapped over here, so we need to skip it. And next rocket supposed to be this one, but this one as well is overlapped with the time range compared to the first one. And then our next rocket would be this one. And we have the option of two, this or this, but this rocket as well, you know, overlapped with the time range as well. So our next rocket would be this one. So there are 3 rockets available to launch as many rockets as possible within the given time. So in this example, we have to use some techniques to compare between the last end time with the starting time for the rocket. There we go. Well, first things first, I'm gonna write down the test case. We have 6 rockets, and I'm gonna throw in the launch time of the rocket randomly, 5, 7, 8, 9, 1, 4, 5, 9. There we go. I'm gonna save it. Well, I need the vector, and I need the algorithm, because we're gonna use the sort function. First things first, we need the vector. Before we do that, we need the structure as well. Contains the starting time and end time. I'm gonna name it rockets. Well, we need to input starting time and end time, and we need to push back to the rockets. Starting time and end time. There we go. And then, like I said before, we need to sort out some data based on the end time. Based on the compare function. And it's going to be rocket A and rocket B. And our priority is rocket A all the time. So I'm going to sort it out based on the end time. There we go. The rocket A's end time, it should be earlier all the time than the B's end time. So I'm going to check the data first, whether the data is sorted out perfectly or not. Oh, before we do that, I have to open up the file, the text file. There we go. Well, it is sorted out based on the end time, as you can see. And first things first, we need to count some data. Launch count. Start from 0. And to trigger the first update, I'm gonna set the last end time with the negative value, with -1. And we go through the size of the rockets. And we need to compare between the last end time and the starting time. So if the rocket's starting time is smaller than the last end time, I'm gonna skip this process. Otherwise, we're gonna update the last end time with the rocket's end time, and we're going to increment this launch count data like this. And I'm going to print it out, this data. It must be 3 in this test case. 3. There we go. Well, let's move on to our last example for today. Imagine you work at a busy coffee shop. So the 5 orders in this example are placed at the same time. And so if we process the orders in this order, each order makes the people behind it waiting. The first order affects 4 people, and then 3, 2, 1, and finally none. This results in total waiting time of 26 minutes, which I already calculated. But we can reduce the waiting time from all customers by finishing the small orders first. Now, the shortest order, which is 1 minute, affects 4 people, and the next one affects 3, and so on. This reduces the total waiting time to 19 minutes, which is the smallest value. So we can reduce the waiting time by using the greedy algorithm like this. And so how can we represent this kind of decreasing pattern mathematically? Well, it is pretty simple. So we have the number of orders, which is n. Well, in this example, it is 5, but I will consider it as a variable. And we can subtract the t, which is incremented like this, from 0 to 4. And then if we subtract 1 again over here, this value represents how many orders are still waiting after the current one. So we can multiply this value with the coffee making time, which will be accumulated to the total waiting time. So this is our strategy for this problem. So let's move on to the coding part. Well, first things first, we need to complete this text file. We have 5 orders with 3 minutes order, 1 minute, 4 minute, 3 minute, and 2 minute. 3, 1, 4, 3, 2. Well, I'm gonna save it. And this order is the order of this, as you probably can tell. And let's write down the basic code first. I need the vector. We use the algorithm. We use the sort function. I'm gonna open up the text file. There we go. And then there is the number of the orders. The number of the orders. There is the integer type orders, which contains the time, the coffee making time. So it's going to be time. I'm going to push back some time value to the orders vector. Push back time. There we go. And then we need to sort out based on the smallest value, which is ascending order. So begin and well, the ascending order is already the default setting. So as you probably can tell, it is already ascending order. But if you want to know more, you can just write down this code for the ascending order as well, which is already the default setting. There we go. And so Now we're gonna accumulate the total waiting time. And before we do that, I'm gonna figure out the each waiting time. And I'm gonna accumulate the each waiting time to the total waiting time later on. There we go. And then, like I said before, this is how we figure out the value of each waiting time in each order. So yeah, maybe I can just print it out, this value. It must be 19. But if I don't sort it out, the customer should be waiting for 26 minutes, which we already gone through already. There we go. So this is all about today's video, and I hope you find it very useful through this video. Well, thanks for watching, and see you on my next video. Bye guys.